Hi everyone, so we're gonna do some more practice with this chi-squared goodness of fit test, and I just want to walk through another problem with you, and then hopefully that will help understand a little bit more. So here we go. It says the table alongside shows the grades received by the university students taking a second-year computer science course. In the following semester, a new coordinator is appointed to the course. The new coordinator is concerned by the high number of high distinctions and distinctions awards and wants to determine if the course should be adjusted. And then it says that they are considering, it is considered usual if 5% of the students receive high distinctions, 10% receive distinction, 15% receive a credit, 40% receive a pass, and the remaining 30% receive a fail. Okay, so we want to conduct a chi-square goodness of fit test to determine if this course should be adjusted with a significance level of 5%. Okay, so our H sub 0, our null hypothesis, should be that it should not be adjusted. And then our, so course not adjusted, so keeping it the same. And then the opposite of that would be that the course is adjusted. That would be a good thought. Okay, so how do we know that we have to use the chi-squared goodness of fit? Well, here we just have one categorical value here. We have high distinction, distinction, credit, pass, fail, and then we have a frequency. So that's how we know that the chi-squared goodness of fit is the best option. Our significance level is 5%, so my alpha is 0.05. My degrees of freedom, well, I have 1, 2, 3, 4, 5 categories. So 5 minus 1 means my degrees of freedom is 4. And then now we need to fill in our table here. So our observed, we have, what do we got for observed? 16, 21, 21, 59, and 34. So those are our 5. Now, our expected, in this particular case, I tell you in the problem what that expected value should be. So 5% is a high distinction, 10% is a distinction, etc., etc., etc. So that information right there is going to help us find that expected value because I'm giving you that percentage. So remember, our expected value is going to be your total, which in this case is 151, times that percentage. So for high distinction, I am going to take, I'm going to scroll down here, I'm going to take my 151, and I'm going to probably run into more of this table, but I'm going to take that 151 and I'm going to times it by 5%. And then for the next one, it said it was 10%. So then I'll take 151 times 10%. And then I'll take 151. The next one is 15%. So then I'll take it times 15%. And then I'll do 151 times 40%. And then 151 times 30%. And when I do that, I'm going to actually bring these. So this is what we're going to have L1 and L2. So our L1 is the observed, which is our 16, 21, 21, 59, and 34. And then when I take 151 times 0.05, I get 7.55. And then I get 15.1, 22.65, 60.4, and 45.3. So we've figured out our expected, so now we have to go to our calculator. And we go to Stat, hit Enter, clear out your L1 and your L2, and then let's enter in our values. So L1 should be 16, 21, 21, 59, and 34. L2 should be 7.55, 15.1, 22.65, 60.4, and 45.3. And then we're going to go to Stat, scroll over to Test, scroll down to the chi-squared GOF test. We found our degrees of freedom was 4. Remember, observed must be L1 and expected L2. And then we're going to calculate it. And we find our chi-squared value to be 14.7. And our p-value, come back up here, our p-value is 0.0053. So now we need to think about, are we going to reject our h sub 0? Well, remember, in order for us to reject, our p must be less than our significance level. So we found our p to be 0.0052, and our significance level is 0.05. So in this case, 0.052 is less than 0.05, so we are going to reject h sub 0, which means that we can conclude the course should be adjusted. And that is how we do our chi-squared goodness of fit. Again, sorry I do not have the 83, but please go to my website to watch that video on how to use the 83. And then you can run this through with your 83 calculator and see that you get the